Hello everyone. In today's video, we are going to solve a numerical problem based on water cooler. We are going to calculate the outlet temperature of the water when the cooling capacity and volume flow rate of water inside the water cooler is given to us. So in this numerical problem, we have a water cooler which has a cooling capacity of 1 ton of refrigeration. The volume flow rate of water is 200 liters per hour. The inlet temperature of water is equal to 30 degrees Celsius. Let us say it is a T1 temperature. We are going to calculate the outlet temperature of water, which is equal to, let's say, T2 degrees Celsius. The specific heat of water is equal to 4.18 kilojoule per kg Kelvin. So the cooling capacity or the rate of heat removal inside this water cooler can be written as Q dot is equal to m dot Cp delta T, where Q dot is the cooling capacity which is given to us 1 TR, 1 ton of refrigeration, which is equal to 3.51 kilowatts. M dot is mass flow rate of the water inside this water cooler. Cp is the specific heat of water which is already given to us. Delta T is the temperature difference of the water at the inlet and at the outlet. So we know that temperature at the inlet is 30 degrees Celsius. At the outlet temperature we want to calculate. So if I want to get the kilowatts of unit here, mass flow rate should be used in kg per second. Cp should be used in kilojoule per kg Kelvin, and the temperature difference should be used in Kelvin. So if I can cancel here kg, Kelvin, Kelvin. So I will get kilojoule per second, which is nothing but kilowatts. Now, how do I calculate the mass flow rate of the water, which is not given to us? So I will use density of water formula, which is equal to mass per unit volume. Instead of using mass per unit volume, I will say mass flow rate divided by volume flow rate. So from this, mass flow rate equal to density of water multiplied by the volume flow rate of the water. Volume flow rate of the water is already given to us. So what units we should use in this? So I will use density in kg per meter cube, and volume flow rate should be in meter cube per seconds. In this, meter cube will get cancelled. I will get kg per second, which I can use this kg per second in cooling capacity formula. So the first step, we are going to calculate the mass flow rate of the water in kg per second, and then we are going to use the cooling capacity formula in order to calculate the outlet temperature of the water. So before we calculate the mass flow rate of water in kg per second, as discussed, we will need this volume flow rate to be in meter cube per second. The given volume flow rate is in liters per hour. So let's convert this liters per hour into meter cube per second. 1 liter is 10 raised to minus 3 meter cube. So 200 multiplied by 10 raised to minus 3 meter cube. 1 hour is 3600 seconds. So the volume flow rate is equal to 5.55 multiplied by 10 raised to minus 5 meter cube per second. So let's calculate this mass flow rate here, which is equal to density of water multiplied by the volume flow rate of water. Density of water is, we already know that, 10 raised to 3 kg per meter cube multiplied by the volume flow rate, which is equal to 5.55 multiplied by 10 raised to minus 5 meter cube per second. From this, mass flow rate is equal to 0.0555 kg per second. So here meter cube get cancelled and you will get kg per second. So the volume mass flow rate of the water is equal to 0.0555 kg per second. Now let us calculate the outlet temperature of water using cooling capacity formula, which is Q dot is equal to m dot Cp delta T. Delta T here is the temperature difference between water inlet and outlet. So I will write delta T as higher temperature minus lower temperature. Now, should I use this temperature difference in Kelvin or degree Celsius? It doesn't matter whether we will use degree Celsius or Kelvin unit here, because if T1, if I convert this T1 into Kelvin, I will add 273 here. So minus T2, I will also convert this T2 into Kelvin. So I will add 273, but because of this negative sign, that 273 will become minus 273, and this 273 and this 273 will get cancelled anyway. Either you use degree Celsius or Kelvin. So we will just use the degree Celsius because it doesn't matter. So now let us calculate the outlet temperature of water using cooling capacity of the water cooler. So the cooling capacity is equal to m dot Cp delta T, which is higher temperature minus the lower temperature of water. So the cooling capacity is equal to 3.51 kilowatt, that is equal to m dot, which is mass flow rate, which is 0.055 kg per second. Cp is equal to 4.18 kilojoule per kg Kelvin multiplied by the temperature difference. Higher temperature is at inlet 30 degrees Celsius minus the outlet temperature, which is T2. So from this 3.51 equal to, if you solve this is 0.231 multiplied by 30 minus T2, and from this T2 is equal to 14.87 degrees Celsius. So the outlet temperature of the water in this water cooler is equal to 14.87 degrees Celsius.